Focus for today's lesson is to interpret a redox reaction. So we have a redox reaction, two of them actually listed over here. One where the oxidation states or the charges are already assigned, okay, as we see in this example over here. And we can also have a redox reaction where the charges are not yet assigned, and we have to determine that. Based on that information, we can answer questions like, determining the oxidized or reduced species, or determining the number of electrons lost or gained. So here are some helpful tips. If you want to identify an oxidized substance, it's usually the substance left of the arrow has the smaller charge. So say, for example, I'm going to write out an equation over here. Say, for example, I have A plus B forming AB, and the oxidation numbers are assigned, like, for example, this is 0 and that's 0, and this is plus 2, and that's minus 2. We see that the substance to the left of the arrow, this one over here, has a smaller charge. Okay, so when you notice that A on the left side of the arrow has a charge of 0, and A on the right side of the arrow has a charge of plus 2, the substance with the lesser charge is the oxidized substance. Likewise, if you want to identify a reduced substance, then that reduced substance has a greater charge to the left of the arrow. So going back to this example over here of A plus B producing AB, and the assigned oxidation numbers are assigned, we see that B has a charge of 0 on the left-hand side, and B on the right-hand side of the arrow has a charge of negative 2. 0 is greater than negative 2. Therefore, B is the reduced species. All right, so we're going to take a look at a redox reaction where the charges are already assigned, and we're going to interpret this one by one. So we have here 3 magnesiums reacting with 2 aluminum ions to form 3 magnesium ions and 2 aluminum elements. So what do we notice here? Magnesium 0 has a smaller charge than aluminum plus 3, okay? So if magnesium 0 has a smaller charge, so smaller charge, therefore magnesium 0 is oxidized. Okay. Also, we notice that going from magnesium 0 to magnesium 2 plus, we have lost 2 electrons. Okay. So magnesium 0 loses 2 electrons. Okay. Magnesium 0 has an oxidation number that increases from 0 to plus 2. So I'm going to write that down also. Oxidation number increases from 0 to plus 2. How would we write the half reaction? Well, we have magnesium with a charge of 0 on the reactant side, and then it becomes magnesium with a charge of 2 on the product side. So because magnesium got oxidized, it lost electrons, we need to indicate that loss by writing it on the right side of the arrow. So this goes to show you that magnesium lost 2 electrons, and you can even double check this by looking at the sum of the charges on both sides of the equation. If you recall from the previous video, we have to make sure that every equation that we have is balanced in terms of not just mass, but also charge as well. So if on this left side of the arrow I have an overall charge of 0, okay? On the right side of the arrow, I also have to have an overall charge of 0. So magnesium has a +2, and 2 electrons is really 2 -1 particles, and that's -2. And now I have 0 equaling 0, and now I know that it's balanced. Okay, so just to recap here, we notice that magnesium, gets oxidized. It loses 2 electrons. Its oxidation number increases from 0 to +2. And if we were to write out the oxidation half reaction, it would be magnesium 0, forming magnesium +2, losing 2 electrons. All right, let's take a look at aluminum. So aluminum has a larger charge than magnesium, okay? Therefore, aluminum gets reduced. So I'm just going to write this here. It has a larger charge, okay? Aluminum +3 gets reduced. It also gains 3 electrons. If you take a look over here, it goes from a charge of +3 down to a charge of 0. That means it gained 3 electrons. Just take a look at a number line and go from +3 down to 0. You're going in the negative direction, and that means that the oxidation number has decreased, and therefore you've gained electrons as a result. So aluminum +3 has gained electrons. Gains 3 electrons, okay? And the oxidation number decreases. From +3 to 0, okay? How would we write out the half reaction? Well, we start off with the aluminum ion, which is +3, and because it gets reduced, it gains 3 electrons and becomes aluminum with a charge of 0. Also, you can check to see that it's balanced. So aluminum has a charge of +3. 3 electrons makes a charge of -3. The charge of aluminum on the other side of the arrow is 0. +3 and -3 is 0. 0 equals 0, and this half reaction is also balanced. Let's take a look at the products. So the species to the right of the arrow in a redox equation, like magnesium and magnesium ion and the aluminum element, are the results of the species on the left side that have lost and gained electrons. Therefore, the species on the right are neither oxidized nor reduced. Okay, I'm going to repeat that again. The species to the right of the arrow in a redox equation, meaning the products, are the results of the species on the left that have lost and gained electrons. Therefore, the species on the right are neither oxidized nor reduced. Just to show you in a different way, if I were to take a look at the magnesium element over here and compare it to the magnesium ion over here, the process from going from being an element to an ion means that I'm just gonna magnesium has gotten oxidized. So from start to finish, magnesium was the thing that got oxidized to become the magnesium ion. Aluminum got reduced, okay? So aluminum began as an ion and then got reduced to an element, okay? So I'm just going to write this out over here. Species on the right or substances are neither oxidized nor reduced. They are the products of what happened before the arrow, okay? So they're the result of the oxidation and the reduction. Oxidation and reduction doesn't happen to them, they are the result of it. Okay, so this is an example of a redox reaction where the oxidation numbers are assigned, and all you have to do is just take a look at the numbers and see, are they going up or are they going down? Are the charges smaller? Are the charges larger? What's getting oxidized? What's getting reduced? How many electrons are being lost or gained? So on and so forth. The next reaction is a reaction where the oxidation numbers are not yet assigned, and we have to assign them. So let's do it. I'm going to use a different color pencil over here. Okay, so when you have an elemental substance, a substance on its own, its charge is 0. Okay, you can refer back to the first lesson in this unit. It goes through all the rules. Okay, let's take a look at H2SO4 over here. Hydrogen typically is +1, and oxygen typically is -2. Okay, sulfur, on the other hand, we need to figure out. We should go to our periodic table, but just in case, we can do some simple math to figure this out as well. So, I have 2 hydrogens with a charge of +1, so that's really +2. I have a charge of sulfur that I don't know, that's +x, and then I have a charge of oxygen, okay? So I have 4 oxygens with a -2 charge, which makes a -8 overall charge for oxygen. Remember that the sum of all of the charges have to add up to 0 in a neutral compound, so let's make that equal 0, and let's combine like terms. 2 minus 8 is -6. So x, just going to zoom in over here, -6 equals 0. So therefore the charge of sulfur is +6. So that I'm going to put right over here. Okay? Let's take a look at calcium sulfate. I know that calcium has a charge of, let's zoom in over here, +2, and oxygen has a charge of -2. I need to figure out what the charge of sulfur is over here. So again, I'm going to just do some simple math to figure this out. So I have 1 calcium, okay, just 1 calcium with a charge of +2. So I'm going to write out +2. I'm going to designate X for the charge of sulfur, plus X. And I'm going to take into account the charge of oxygen. I have 4 oxygens with a charge of -2, which makes an overall charge of -8. And we know that the sum of all of the charges in a neutral compound have to add up to 0. Okay, let's do the math. +2 plus X minus 8, that's X minus 6 is equal to 0. And I solve for X, or the charge of sulfur, and that's +6 as well. Okay. Let's take a look at elemental hydrogen that has a charge of 0. Let's point out over here what's changing. So I start off with calcium, okay, on the left side of the arrow. And let's take a look at calcium on the right side of the arrow. Oh, look, it became +2. So what I'm going to do is I'm going to note that. I'm going to note the change that calcium is going from 0 to a charge of +2. When you're going from 0 to a charge of +2, is that oxidation, a loss of electrons, or reduction, a gain of electrons? It's a loss of electrons, okay? So calcium, therefore, is oxidized. Calcium 0 is oxidized. This is the oxidized species, okay? It loses 2 electrons, okay? And its oxidation number, whoa, that's messy. Its oxidation number goes from 0 to +2. Okay, if we were to write out the oxidation half reaction, it would go something like this. It starts off with calcium with a charge of 0, and then it becomes calcium with a charge of +2. Okay, I have lost 2 electrons, and I will indicate that by writing +2e minus. I can also check to see if this half reaction is balanced. Okay, the charge on the left-hand side of the arrow is 0. And the charge on the right-hand side of the arrow is +2 and -2, which also adds up to 0. All right, let's take a look at hydrogen. We start off with a +1, and then we end up with a charge of 0 on the product side. So I am going to note that as well. So we have hydrogen with a +1 becoming hydrogen with a 0. Okay, so when you're going from +1 down to a 0, are you getting oxidized or reduced? You are getting reduced. Okay, I'm just going to zoom in here and take some notes. So hydrogen, sorry, H+, is reduced. Okay, it gains 1 electron by going down from 0 to +1. Sorry, by going down from +1 to 0. So oxidation number goes from +1 to 0. Okay, and if we were to write out the reduction half reaction, we would write it like this. We have 2 hydrogen ions. Okay, and I just want to point to that over here. We have 2 hydrogen ions with a charge of +1 forming 2 elemental hydrogens. And it does that by gaining 2 electrons and becoming H2 with a charge of 0. To check if it's balanced, all you do is add up the charges on both sides. So 2 times +1 gives me +2, okay? 2 electrons, so 2 times -1 gives me -2. And that should equal to 0, which is the charge of my hydrogen over here. So +2 and -2 is equal to 0, and that's it. Okay, so when you have a redox reaction and the oxidation numbers are not assigned, it's up to you to assign them. So you have to remember the rules and assign them accordingly. If you have a substance or a component of a substance where you don't know the charge, you can use some simple math to figure out what that number is. And just take a look here. We focus mostly on calcium and hydrogen. If you look at sulfur and oxygen, those numbers don't change. And that's okay. All you really need are 2 substances, 2 components in a reaction that will gain and lose electrons. There can be plenty of other things hanging out in the reaction that don't really have an effect. That's actually called a spectator ion. It doesn't really do much except just hang out and watch the show. So it's okay if you come across species or substances whose oxidation numbers just don't change at all. That's perfectly fine. As long as you can identify 2, for example, here we have calcium went from 0 to +2, and then hydrogen went from +1 to 0. That's it. If there's other stuff that doesn't change, don't let it sidetrack you. It's simply a spectator ion. It just watches the show. All right, so let's just take a look at the products over here. So we're left with calcium sulfate and hydrogen. So these are the result of what happened on this side. Okay, so you had calcium getting oxidized, hydrogen getting reduced, and this is your result. And so therefore, this neither gets oxidized nor reduced, and that's it. Okay, so I hope that you were able to practice interpreting these redox reactions with me, and if you have any questions, please feel free to email or comment or post your questions on Google Classroom. All right, guys, time for you to practice.